Welcome back. Today we're going to explore a material that is stronger than your parents' crumbling relationship, no matter how much they want that divorce. That's right, today's topic is carbon fiber. To begin, let's talk about the history of how this all started. According to many sources, the first creation of carbon fiber is accredited to Roger Bacon, who accidentally produced it using petroleum. However, just like any misplaced paternity test, there's actually recorded sources of carbon fiber earlier than this. For example, in the late 1800s, when electricity was being used in a mind-blowing application, the light bulb, the inventor Thomas Edison, who considered himself the father of everything as any narcissistic bastard would, is accredited with an earlier instance of carbon fiber creation. Totally by chance, Edison took cotton and bamboo and formed them into filament threads, baking them at high temperatures like a delicious batch of fresh cookies. Now you might be saying, Harry, this isn't carbon fiber, this is just cotton balls and bamboo in the oven. However, if you know anything about these two materials, they consist mainly of carbon, and so when heated to very high temperatures, they go through what is known as carbonization and take on the shape of carbon fiber. Even with this, Edison never really used carbon fiber as tungsten was more preferred at the time, except for in some applications like on Navy ships because the tungsten filament was just not as good with ship vibrations as carbon fiber, but no one really cares about this, so let's just keep going. Carbon fiber, as many would think, is really just a collection of carbons. The reason Roger Bacon is accredited with being the father of carbon fibers is because Roger Bacon created the first high-performance carbon fibers in Cleveland, Ohio. And no, this is not like everything else that comes out of Ohio, at least this happens to be somewhat normal, usable, and realistic. The structure of carbon fiber, in the most basic sense, is a collection of graphitic sheets oriented parallel to the fiber axis. And while this sounds very complicated, just think if you were to take a bunch of plates and kind of wind them together if they were flexible. Oh crap, wait, no, don't do that. Don't do that because they'll break. No, never mind. If they were flexible and you did wind them together all along a similar axis, this is kind of what it would look like. The orientation of these graphitic sheets adds a lot of strength because if you recall from the previous video about diamonds, you'll know that carbons bonded to other carbons can add strength in the direction of the bond. What makes the strength of carbon fibers unique is the fact that they possess strength in an anisotropic form. Along the axis, they're very strong. However, when they are perpendicular to the axis, they are not as strong. While most of you probably don't have carbon fibers just readily available at your house to test this, I would suggest taking a piece of paper and trying to pull it apart with one hand on either end. You'll notice that it gives a little resistance. Now take the same sheet of paper and position your hands at the top of the edge. Begin to tear the piece of paper. You'll notice that it doesn't really have as much strength here. Carbon fibers work in a similar sense, where they're stronger along the fiber as opposed to perpendicular to the fiber or normal to the fiber axis. Now that you know what carbon fibers are, let's talk a little bit about what they're used for. There was a phase, I think it was about 5 to 10 years ago, where everybody happened to use carbon fibers in practically everything. Come try our new carbon fiber tennis racket. Come try our new carbon fiber sink. Come try our new carbon fiber toothbrush. Come try our new carbon fiber condoms. And while carbon fiber in some of those applications is good, it's not really necessary in others. The real reason to use carbon fiber as opposed to other really strong materials is because carbon fiber has a high strength to weight ratio. Imagine this. There is a guy who weighs 850 pounds and can bench press 1,000 pounds. And then there's another guy who weighs 400 pounds and can also bench press 1,000 pounds. Which guy do you want to be working on a plane 20,000 feet in the air? This is carbon fiber. Carbon fiber is the small, lightweight guy that can do just as well, if not better in most cases, than big, massive steel parts and components. So originally, for mainly governmental applications, carbon fiber was an absolute blessing because it didn't matter how much it cost to make. However, as research continued, and since carbon fiber isn't really that hard to make because it's really just derived from heating a precursor to extremely high temperatures and orienting it in a furnace, which sounds complicated but really isn't that complicated and just uses a lot of power, like your Bitcoin mining rig, carbon fiber all of a sudden became very desired in a lot of very prominent industries. Things like aerospace, wind energy, and even the automotive industry looked at carbon fibers and said, we don't have to sacrifice strength and gains just to lose a little bit of weight. So they started to implement carbon fiber in certain parts and components of the vehicles and devices. Because there are some people on the internet that will tell you that carbon fibers are not as strong as steel, I'm going to just get a little technical for a second because I hate people and I'm sorry for that. There is numerous documentation and many papers out there that have compared carbon fibers reinforcing things in composites to structural steel, and just basic characterization of regular carbon fibers compared to structural steel. So citing this below, I'm going to say carbon fiber, the standard carbon fiber, is about 1/6 the density of standard European structural steel S355. And while this is how the densities compare, carbon fiber is actually about 6 times stronger in terms of tensile strength than that steel. And I'm going to put this paper that claims this down below for all the people on the internet who have 3 brain cells and are still trying to find their 4th. So that's about all the stuff I can talk about today without blowing my brains out while I try to educate the masses. I'm going to get back to drinking, and if by some absolute anomaly you were able to learn something from this video, please hit that like button. And if you didn't, write a comment in the most unreasonably stupid English so that I can possibly stare at it at 2 o'clock in the morning while I sit awake at night contemplating my life decisions. Have a great one, and maybe I'll see you again.